Okay, this is part 2 of rules of exponents. So we have a times b to the nth. This is one we didn't talk about in class because it really only matters when we're dealing with variables, and right now we're dealing with just regular numbers. But I'm going to show you how it works anyways. We could multiply 2 and 5 together and get 10 and just have 10 to the third, and that's great, that's fine. But to show how this rule works so that if one of those was a variable, how we would do this, so if it was like 2 times x to the third, like that, this is where you would need this rule, where this rule would show up. So 2x, which means 2 times x to the third, would be 2x times 2x times 2x. Now there's this rule in math that says that if things are all multiplied together, which the 2 and the x and all of that is all multiplied together, we can switch it around to whatever order we want. So I'm going to put all the 2's together. I took 1, 2, 3 2's and put them together. And I'm going to put all the x's together. And this gets me 2 to the third times x to the third. Now I know some of you are saying, I could just get 8. I know you can, and that's great. But we're not getting to that step yet. We're just showing how do we rewrite this with more exponents. Because up here, we don't have any numbers at all. So we want to see what happens to the bases and the exponents. How many 2's do we have? And then later on, you can make that an 8. That'd be great. But for what we're doing now, we want to see what happens. So you can almost see this like the distributive property. That exponent goes to both of them because it's saying there should be 3 2's and 3 x's. So up here, it's saying there should be n a's and n b's. So it looks like that. So write that in your third one. This fourth one, boy, you better know. You better know. Say it out loud. Anything to the 0 power. Let's do 2 to the 0 power. Say it out loud. Tell your brother, your sister, your dog, your mom, your dad, whoever's there, your wall, your stuffed animal, whatever. Tell me. Okay. There are 3 answers that I heard. I didn't really hear them, but I'm going to pretend like I did. I heard 0, I heard 1, and I heard 2. Think about it. Which one is it? Okay, if you remember, we talked about this meaning that all the 2's canceled out and there were no 2's left. When everything cancels out, like in that division problem, that fraction, it means that it all equals 1, not 0 and not 2. 2 to the first means, hey, there's only 1 2, so write that 1 2 down. This means there's no 2's left, so all that's left is a 1. Anything to the 0 power is 1. Do you remember that quiz that I threatened you with, but no one had to take it, called the I Didn't Listen to Mrs. Lamon quiz because you forgot that that was 1. That's a really important rule. Remember that rule. So that's that fourth one. Next, division. I like division ones. Remember that a fraction bar means division. So let's write it with actual numbers and see what we can come up with. If I have 2 to the 5th over 2 to the 3rd, we can expand this out and we get 5 2's on the top, 3 2's on the bottom. And what do we get to do when we have that? We get to cancel it. When we cancel it, it equals 1 because that's just 2 divided by 2 and 2 divided by 2 and 2 divided by 2. And so now I know you're tempted to say 4, which it's true, it is 4. But remember, we're trying to write it with exponents so we can write a rule when they can't be simplified, when they're letters and not numbers. So how many 2's are left? Just like a ballerina princess, there's 2 2's left. So to get from 5 and 3 and making it 2, look at those exponents, we would subtract them. So up here at the top, when we have this division problem, it means we subtract the top exponent minus the bottom exponent because they would cancel each other out. Okay, my time's going to run out and I have a few more to do. I'll do one more video.